Well, see, I don't know that why you are repeating the same mistake. In last all the questions you have done same. Though I am repeatedly explaining the step-by-step process. Repeatedly, I am explaining the step-by-step process, and I am making it very simple. I made it very simple in the last few questions discussion, and almost all the circuits I have given in one pattern only. I have given the problems based on one particular pattern of arrangement of resistors. I didn't try any other type of network of resistors. First solve this trick and then I will explain about the other. There are so many types of networking of resistors is possible. So this is the one out of them. In this pattern we can simply calculate the effective resistance of n number of resistors given if the network type is like this. See, what is the type? All the resistors I have given in one line only, right? Just, I mean, like you see the extreme points A and D, all the resistors are in between A and D only. All the resistors are available in between A and D only. So out of these extreme, in between extreme point, in between A and B, there is only one resistor. But in between B and C, there are three resistors. So I said that whenever you see that there are multiple resistors appearing parallel to each other in between any two specific point, then our objective should be to reduce the network of those three resistors. As we can see, three resistors, though they are of same value, R2, R3, R4, these three resistors are parallelly connected in between B and C. So we must try to reduce this network of three resistors into their effective one, that is the single one who can replace these three resistors. Similarly, in between C and D, there are again two resistors parallelly connected to each other. Okay, 6 ohm and 6 ohm each. So what did I say? I first explained you to reduce that branch, those resistors to be reduced to the single one, those who are parallelly connected between any 2 points. So here we can see between B and C there are three resistors of 9 ohm each. In between C and D we can again see there are two resistors of 6 ohm connected parallel. So if I do the calculation of RBC, that means if I want to reduce this, if I want to know the single resistor who will replace these three resistors connected in between B and C, then what should I do? The assumed effective is RBC because B and C are those 2 points in between, these three are parallelly connected. So 1 by RBC will be equal to 1 by 9 plus 1 by 9 plus 1 by 9, isn't it? So all three parts are same, so I can write down it is 3 by 9, so simply it is 1 by 3. Yes or no? So from this part I can say RBC is straightway 3 ohm. RBC is straightway 3 ohm. Once we get the value of RBC, similarly we can reduce the two resistors available in between C and D, so they are also parallel. So in between C and D, so RCD, in between C and D I am assuming the effective resistance, naming it as if RCD. So that is equal to 1 by 6 plus 1 by 6. So that means it is 2 by 6, that is 1 by 3, isn't it? 1 by 6 plus 1 by 6 equal to 2 by 6, that is 1 by 3. That means RCD we are getting it of 3 ohm. So see, in between B and C, replacing these three resistors, we can do it, we can replace it by 3 ohm. Similarly, in between C and D, we can replace it by again another resistor of 3 ohm. So ultimately what we are getting, there was a single resistor of R1 that is of 4 ohm. available between A and B, let it be the single one, that is in parallel with 3 ohm between B and C, which is further in series with another 3 ohm between C and D. Yes or no? So finally we can get one branch of all 3 resistors connected in series across the given battery of 20 volt. So 4 ohm plus 3 ohm plus 3 ohm. So R effective of the network will be 4 plus 3 plus 3. So it is ultimately 10 ohm. It is ultimately 10 ohm. Yes, finally, lastly you have done it correct. Finally it is 10 ohm. So single effective resistance replacing this entire network is of 10 ohm. So that means current drawing will be applied voltage by effective resistance. So that means it is of 2 ampere. Got it? As I said in the previous questions also, unless and until you make the correct calculation of effective resistance, you won't be getting the correct value of the current drawn by the network of resistors from the battery. Okay. So this is the kind of network we have tried to discuss today, and being in IIT JEE foundation course content, I know that you are doing the things little bit more than your school level kind of things, but yes, as because you are aspiring for JEE from this class 8 onwards, so that means you should learn the tricks and techniques from now onwards, so that you can take the lead over the others, isn't it? Definitely you need to concentrate a lot while you should listen the explanations carefully. You should revise the lectures from app once it gets uploaded. You know that I repeatedly say this particular lines at the end of every session, that you should revise each and every lessons, each and every lecture you should revise as per your convenience, because without revision you won't be able to recall these concepts, because these are the things what is much beyond your school content. So that's why you should definitely spend time in doing the revision, and you are having the advantage of getting the same lecture again in your app for revision. So you should do it. If you are not revising it, so that means it is your mistake. You are misusing the advantages, the options, the facilities given to you.